pleasure to welcome back Simon, who I won't make the royalty jokes, but it's really nice to have you back. Looking forward to hear from your presentation.
Great, thank you. It's very nice to be back, only my second time in New Zealand. So I'm Simon McIntosh Smith. I'm a professor at the University of Bristol. I was just chatting with one of the other attendees here. Why Bristol? Bristol's actually a real hotbed of chip design in the UK, apart from Cambridge, where ARM's based. Bristol's the other big location. It's where InMOS was based. Those of you who've been around in high-performance computing for a very long time. InMOS and then ST Micro and lots of other startups ever since. More recently, companies like GraphCore were based in Bristol. So that's why I am there. Spent the first 15 years of my life as a chip designer. So I was a semiconductor person in industry. And I've now been at the university for 17 years, which I can't believe it's gone incredibly quickly. But we've recently, in the last couple of years, started a new supercomputer center called the Bristol Center for Supercomputing, or BRICS, which is running Isambard AI, and I'll tell you all about that in a minute. So we started BRICS only a couple of years ago. We've grown very quickly. We're already up to a team of about 30 people. And we're running a lot of the national services for the UK. It's over £300 million worth. So what's that, 600-700 million New Zealand dollars over the next 5 years. And we're still growing. We still have more projects coming on. This is most of the team back in December last year. And in fact, the lady right over on the right-hand side, there's Emma Rose. She's our center manager. And she is a Kiwi, and she is from Christchurch. So this is her hometown, but it's a great team of people we've got. And we've been busy. We've been building lots of different systems, using modular data centers. This is one of the things that's a bit different about what we're doing in Bristol. So we're not using any traditional data centers. We basically started from a clean sheet of paper, and we've used modular data centers. And that's let us go really fast. We've built 2 new modular data centers. And inside those, we've put 3 different new supercomputers, all HPE, as it turns out, in the last 2 years. And so that's starting from scratch. And that includes Isambard 3, which is actually a CPU system. It's based on NVIDIA CPUs, on the Grace ARM CPUs, and then 2 different GPU-based systems for AI, and they're specifically for AI. These are not HPC systems that also do AI. The primary mission is AI. And that does mean we do things a little bit differently. So they're all HP, they all use Slingshot. Isambard 3 is air-cooled, everything else is direct liquid cooled. But the big one is Isambard AI Phase 2. It's nearly 5,300 Grace hoppers. So I was talking about this when I was here last year. We were still building it, so it wasn't all done yet. It's ranked number 11 on the top 500, which is the highest the UK has been for over 20 years. And it's still there in November. And we built it very, very quickly. In fact, it was only just over 1 year to build the whole site from scratch. And I mean, from a car park to a data center with a computer in production. So this is quite a big deal. So last year I showed a time lapse. Some of you who were here last year will remember. And this is sort of a shortened version of the time lapse. So this is the site. That's already the Isambard 3 compound. So that's our CPU-based system was already there. And then it was June the 3rd, 2024, we started to dig the hole in the ground. So this is just a 30-second time lapse of what it takes to build a modular data center. It's mostly a big concrete pad with all of the facilities coming in. So we have power, water. So this is a university car park. The camera is on the top of a university building called the National Composite Center, or NCC. The modular data center already in at that point. Timestamps at the bottom. So we're getting close to this time last year, and I stop it exactly a year ago today. So that's a year ago today when I was here. And so this is what I was showing like a year ago. So what happened next? So this is from tomorrow for sort of the rest of the time. What happened next? The building at the front is where all the power goes, all our transformers. There's 5 megawatts of transformers going there. And this end is the water treatment works. It's all direct liquid cooled, so we need very, very pure water. The system actually went in March, so the system's now all actually in there, and we're still building the site around it. So that kind of gives everyone quite a lot of anxiety. HP was really worried about this, as you can understand. Our builders were a little bit worried about it. But to go fast, we basically did everything at the same time. And then we were powering up the system about now, so now the whole thing should be energized. And we're going through acceptance. So by the end of June, I think the whole thing was actually up and running. And by the middle of July, we had the big minister from the government was going to come and do the official opening, so it all had to be ready. So now you see all the tarmac's gone in. It's starting to look a bit more tidy. And it was actually the 17th of July, the science minister came and opened up the site. So this is what happened over the next few months. And we actually had real use on the system by the time the minister came to open it. So it all kind of worked. We didn't have any big challenges or anything that really sort of stopped us. And today the site looks great. There's lots of different things going on. So the main system is inside here in the modular data center. That's Isambard 3, so it's our Grace system. We've got 4 megawatts, actually 5 megawatts of cooling there. So it's been a great experience. We've had lots of people come to see it. In fact, some of you may have been yourself to come and see the site. But most excitedly, just a few weeks ago, we had Prince William came to see. So there's our future king. There's me and Sadaf Alam, who's our CTO. And we got to show him around. He's a really, really nice man. He's also 6'3". I'm 5'11". He's really, really tall. Hadn't realised he's quite that big. So we. No, he was. Yes. You don't see me in a suit very often, but I think when the royal family come to visit, you put the suit on. Yeah. So that was fun. But I thought what I'd do is share some early experience of running this, and it is an AI service, not just an HPC service. And we're still really in the first months of this. So the data is very new. In fact, this is the very first time I've shared any usage data. So you guys are the first to get this. I was only seeing some of this for the first time myself this morning. So this is really hot off the press information. We're already up to over 1,600 users. So in the UK, population is about 65 million. That's a lot of people. And over 600 projects really just in the first few months. And one of the first things we've learned, because all of us, our experience has mostly been running HPC services in the past, is that AI users are not just like HPC users. They really do have different sets of needs and requirements. For example, lots of the use is interactive. This is kind of like a rarity in HPC. You might have a small number of people, they're doing something interactive, maybe for debugging purposes, but actually a big fraction of AI users are interactive. They're on their notebooks, they're using a Jupyter notebook, something like that, and it needs to be running right now. So we've had to rebalance the way the whole system is working so that we've always got enough of the system available for interactive use so that you can start that up quickly. But we do have some people who still want to use Slurm as well. There's a lot of pull for Kubernetes. Many of our users will have already been running in the cloud of some sort, running on Amazon or Microsoft or Google, and they'll have some sort of standard container, maybe a standard NVIDIA container, something like that. They just want to pull it down onto Isambard and just use it. And if we can make that work, that's great because it really lowers the barrier to entry. Users can be up and running very, very quickly. And a lot of that now works. We don't have full Kubernetes yet, but that's sort of coming. We're still working on that right now. But they definitely a very different sort of flavor. The exception to everything I'm saying is we do have an increasing number of users who we describe as AI for science. And they are often running codes that you would call your classic HPC codes. And it might be that those codes are generating data, which then an AI uses, or it might be an AI is using them to run and check some results. So at that point, you do have sort of traditional HPC as well as AI stuff. So we do have that as well. But I've heard some people describe it as AI for AI rather than AI for science. So AI for AI or your pure AI can look very, very different. So what's actually happened on the system? What kinds of things have been running? Well, the first thing to show is how people have been getting time on the system. And there are different allocation routes in the UK, some of which are actually managed by the government. So in the first few months we've had, it turns out, 3.6 million GPU hours over about 550 projects. And these are the different ways you can get some of that time. One of them is called the AI Security Institute. That's actually part of the government, part of the UK government. So they've actually been allocating more time than anyone else, interestingly. There's another part of the UK government called Sovereign AI, and Sovereign AI is really, really important. And in fact, it was partly one of the big motivations why the government's funded Isn't But AI is to give the UK sovereign capability, so the ability to train large language models, foundational models from scratch entirely in the UK. And there's a special allocation scheme run by the government to enable that. And that's the second largest allocator. It's actually only just behind AI security. It's about 34%, 32%. Then what you might call your more sort of traditional academic research routes, there's AI Research Resource, or AIR Gateway. They tend to allocate slightly smaller projects. That's about 500,000 GPU hours. And then there was an initial kind of ramping up in the first few months that had time that allocated lots of smaller projects. That was to give lots of people a chance to try the system and help us kind of shake it down. So this was lots and lots of smaller projects, bigger projects, and these are even bigger types of projects. So the trend we're seeing is we've started out with lots of smaller things, and now we're seeing fewer, bigger projects. And in fact, we're just starting to allocate projects that are in the 100,000 to 1 million GPU hours. Those are being put on the system right now. That's from an AI for Science scheme and an innovator scheme. So the bigger projects will start to kick in over the coming weeks, and then probably this profile will change a little bit. But that's sort of what it looks like in the first few months. Where do those get used? Well, it turns out most of that time is actually being used by research groups in universities. So academics, 62%, nearly 2/3. Then the government actually itself is a big user, about a third of the time, nearly a third of the time is actually being used by the UK government. And that's really interesting. A lot of that is the AI Security Institute, but there are other organizations as well within the government who've been using a lot of that time. So I thought that was really interesting. We have got industry use on already, and we thought this might come a bit further in the future, so I'm quite surprised. It's only 7%, but actually that's maybe more than I expected this soon. There's about 40 companies already on the system using it, which, given it's still very, very new, is a nice surprise. And then there's a few other, 3% is sort of little bits of other things. So that was interesting. And then we can look at what sort of areas are the projects actually in, and we can actually look at that data too. The numbers on the left are, this is sort of from most to least, top to bottom, and in GPU hours, and then it's in percentage in the chart on the right-hand side. The most popular topic for all the different projects running on the system are healthcare related, medical related, at about 37%. And we thought that was likely to be one of the most popular topics, but it's quite a lot bigger than the second most popular area. So that's proven really, really popular. The next is actually a big group of lots of different things that were kind of difficult to categorize. That's sort of other across both the AI Security Institute and the Sovereign AI schemes. Lots of large language model and natural language processing projects as well, nearly 1 million GPU hours of those. And then lots of other stuff, so bio and genomic, lots of vision and 3D, robotics. It was interesting to see was in there, some stuff specifically about cybersecurity, materials and chemistry. So this is a bit more AI for science. So, and a little bit of weather and climate, but not very much. And a little bit of astronomy and space. Are you allowed to ask questions as you're going? I'm okay.
For the AI for science, like topics like bio, materials, healthcare, are these predominantly running LLMs, or are they running different models like AlphaFold, or are they running simulations? I mean, what's the mix here?
it's a whole range of, there's probably 100 projects in there doing a whole range of different things. I've got more detail I can tell you sort of offline about what different things are. We do have people running AlphaFold. There's a project called OpenBind, which was another recent thing that the government sort of invested in. Lots of people using OpenFold, all sorts. I've got the actual list of projects I can sort of talk you through. Yeah, so it's all sorts of different things. I'm going to show you a couple of specific examples actually as well, so you get to see that in a minute. The other thing that we've noticed is this is still changing rapidly. So if I showed you this chart again in another month, it would probably look completely different. So this is all still very new. It's all still evolving. It's not at all settled down. Again, that's another difference to HPC. If we were running an HPC service, we could probably guess what the top 3 or 4 projects would be now and roughly what fraction of the machine they'd use. Whereas with AI, in a couple of weeks, it'll be different. It's all still rapidly evolving. I actually asked, all of that project information's in a spreadsheet. And I asked Copilot, which is built in to all of our things now, to give me some sort of summarization of all the different projects. And it came up with this, and it's actually pretty good. So I didn't write this. This is Copilot, kind of a bit of AI-generated stuff in an AI talk. So it summarized that there's lots of foundation models across all those different projects, including across vision, language, proteomics, climate. There is a lot of generative AI in there too, including robotics. Some weather and ocean. There's not much weather and ocean. There's only about half a dozen projects that are kind of weather and climate related. Lots of healthcare and life sciences. There's a little bit of a breakdown of what sorts of areas there. We mentioned climate, environment. Quite a lot of AI safety, robustness. That's the AI Security Institute will be doing a lot of that. They're trying to deliberately do things like jailbreaks. Is the AIs that we're using, are they safe? Are the guardrails removable or not? And various things about robotics. So it's quite interesting to see what those very broad range of topics are, almost anything and anything you can think of in terms of where AI is being used today. So I've actually picked some of these out to tell you about in a little bit more detail. One of them is, I think most of our nations have got projects to build local sort of sovereign large language models. And we've got one being led by Pontus at UCL in London. And they've been doing a great job. Of course, we do have some of our own languages in the UK. We tend to forget this, don't we? But we do have not just English, but there's Scots and Welsh and Scots Gaelic, a couple of different versions of that, Irish. And some of these languages are known to the mainstream large language models, but they don't do a great job because these are fairly small, don't have many speakers. So does ChatGPT really care about it? So these guys, across all the sort of standard benchmarks, do a much better job on the UK languages than all the sort of standard LLMs do. They also know about things like UK legal, case law. We can spend more time training on all of that. So that's already working, and they're doing a really good job. They've got some great benchmark results compared to some of the big sort of open large language models. These are one of our first big users. These guys can use thousands of GPUs to train that. I mentioned OpenFold in answer to Satoshi's question. These are actually some colleagues in Bristol using OpenFold, and they've got a very interesting project which is actually looking at something called hypertrophic cardiomyopathy, which you will have heard of. Occasionally you hear these news that some fit young athlete was playing football or soccer or some sport, and they had some undiagnosed cardiac condition, and they have a heart attack and they die, sadly, usually on the pitch. Well, it turns out this is what's behind that condition, and they're using Isambard to really understand exactly what's going on so that they can develop therapies and detect the condition sort of before you actually get affected by it. That's a really interesting project. We've just produced a video case study on this, talking to these researchers. If you go to the link, which will be in the PDF a bit later on, you can actually find the video and listen to that piece of work. It's really interesting stuff. And then from the weather and climate side of things, there's a researcher in Manchester called David Topping, who's doing some generative AI. And he's basically doing an expensive, low-resolution simulation of NO2 emissions across the UK. So this is something we care about from a pollution point of view, and be able to give pollution warnings and pollution forecasts. But it's a very expensive simulation. And he now has a generative AI version of this, which takes the low-resolution version and then produces a much higher resolution version, which we actually use for forecasting. We've got a little video here. So here's the UK. So that's the sort of resolution, the expensive low-resolution version. And then he switches to the generative AI, and you can see it's much higher resolution. This is the sort of resolution that you could have a prediction by neighborhood, not just by county or something like that. So that's a Gen AI real application, all running on Isambard. So it's very exciting. The rest of Europe is still at the sort of lower resolution there. Now this, I've got another little video. This is something a bit different for AI, and it's to do with animal conservation. This is not a topic you talk about very often in HPC or AI conferences, but this is another piece of work from colleagues in Bristol, and they're using AI to take all the input coming from camera traps that are all across Africa. So they use camera traps to sort of watch what's happening, or in this case it's a drone actually, with animal migration across Africa. And there are hundreds or even thousands of these cameras. And usually there are human beings, probably postdocs, looking at thousands of hours coming off these cameras, trying to work out what's going on. Well, now you can actually put all that into AI, get the AI to watch all the video and do things like, this is actually not just tracking that's a zebra or zebra, depending on where you're from, but identifying individual animals and knowing which one's which, because all their stripes are slightly different. Same with giraffes. So you can actually know that's a specific zebra, and you can track where it's going over the Great Plains. So this is a short video of some work that's going on. It's got some sound, so I'll stop talking while the video plays.
One of the core challenges in wildlife conservation is tracking the population size and health of a particular species. Conservation teams deploy tools such as drones for aerial surveys, or more commonly, ground-based devices known as camera traps. These are placed strategically across large areas, sometimes spanning entire national parks, and record wildlife in their natural habitat. However, these cameras generate huge volumes of data. A large-scale camera trap deployment can produce hundreds of thousands of videos or images every year. And once they've been collected, each of them needs to be reviewed by an expert to extract extremely detailed information about the species that are present, the behaviors that are being exhibited, and whether or not the individual can be recognized. So in many projects, analyzing just 1 year's worth of collected data can take up to 2 years of human effort. This means that data is being collected far faster than it can be analyzed, and as a result, decisions about wildlife protection are often made using information that's already outdated by the time that it's available. Modern AI can now take over many of the most time-consuming analysis tasks. We have models that can analyze an animal's posture, movement, and interactions to identify their behavior. And we have models that can learn features which are unique to an individual to allow them to be re-identified. By integrating these tools, conservationists can now process massive data sets in hours rather than months or years, allowing them to make informed decisions to protect the species that need it most.
How cool is that? I think it's great to see kind of the real applications, the real capabilities that AI is starting to enable. So that's a sort of a quick taster of what's already starting. And I think in 6 months, we'll be able to come back and have a lot more data on what's really going on and what kind of results people are starting to get using these systems and services. We don't want to get bored. So we're always thinking about what we're going to have to do next. So in Bristol, we're quite busy. So here's a different angle looking down on, that's the first site. So that's what we were just looking at. And we're calling that Isambard Park 1, because that's got Isambard AI Phase 1, Phase 2, and Isambard 3. And they're all separate systems. They can run completely individually. In total is 8.6 megawatts there. The big building, that's the part of the university, that's the NCC. All of this area is a science park. We're about to add another modular data center on the side for a long-term data facility called the Bristol AI Data Facility, or BRAID. So this is coming imminently, digging up a bit more car park. I'll say a bit more about that in a second. And also that there's 4 acres of land available next door. This is only half an acre so far. So we've got 8 times more space. And we've just done some work with the National Grid, who's the power supplier in the UK. And they've now officially confirmed we can have up to 50 megawatts, possibly a bit more, within 2 years. So we've got a lot more space, 8 times more space, 10 times more power than Isambard AI Phase 2. So we're hoping to put that to good use over the coming years. The government has got an ambition to build 20 times more AI capability than Isambard AI by 2030. So we could do a lot of that on that site. But just to say a little bit more about this, all of the storage inside Isambard AI is scratch. It's all just project storage. It's not long term. So we're about to add this. It's going to start off as 50 petabytes. It's all solid state, so it's all flash, with an embedded Kubernetes cluster on the front end for any kind of local processing. It's only using about a third of the rack space in the new modular data centers. We can actually make it up to about 150 petabytes in total. This is actually Dell equipment, so everything we've done so far has been HPE. But this is a Dell modular data center and Dell storage. We've got very high bandwidth from this system into Isambard AI, so it's right next door, and about 100 gigabits today into the national network. Eventually, we can upgrade that to 200 or 400 gigabits. And again, because we don't like to make life easy for ourselves, we're going to go live with that this summer, and we haven't started building it yet. But we have designed it, so it actually looks something like this. This is looking down on the car park. So it's all been designed. The actual modular data center is being manufactured right now. The planning permission application went in a couple of weeks ago. We're due to break ground at the start of April. It'll take April and May to build the site, and then the modular data center will turn up in June, and then we'll start putting the storage in within weeks of doing that. So possibly by July we'll be up and running, and we haven't started building anything yet. You really can, these modular data centers are remarkable. You really can go very quickly with them. So just to summarize all of that, the things we've learned just in the first few months have been that an AI service isn't just a rebadged HPC service. There are things that are different, and we're discovering more different things all the time. This interactive use is quite different. And also lots of small jobs, users kind of working out, does this approach actually work? So the small jobs are important. I think when you run a big HPC service, you tend to look down your nose disapprovingly at small jobs. Why are you wasting my time on my big expensive supercomputer with your 1 node or your 2 node or your 4 node job? Well, actually, they're really crucial in AI. And it's not until you're confident that's working that you then kick off your jobs that could be hundreds or thousands of GPUs. And those users will get to that scale as well. AI for science users are an interesting hybrid. They do stuff that's training a foundation model, and then they'll run GROMACS or the unified model or something that you're very familiar with from a different space, and they're trying to run both at the same time. The AI users are coming from a really broad range of different space. I mean, when we've run HPC services, it wasn't as broad as the AI side of things. We're seeing projects that are really sort of humanities projects, and we rarely saw those in high-performance computing, but they are adopting AI very quickly, and it's an interesting way in for them. And it's changing all the time. So the things I'm showing you now, they're interesting, but in 6 months, a year's time, it'll look very different. And we're not sure what things will still be the same and carry over and what things will be totally different. And then for us, this sovereign AI capability, the capability for the UK to do lots of these things within our own borders is really crucial. And this is not going to go away. I think over the next few years, this is going to be more and more important. And we're seeing the same thing all over Europe and actually all around the world. So it's 5-10 years ago, this is not really something anyone would have thought about, but now it's a really important part of the overall strategy and capability. So I think it's just part of the new normal. If you want to keep up with what's going on in Bristol, the best place to follow us is actually on LinkedIn. You can find the Bristol Centre for Supercomputing on LinkedIn, or go to the website. And we're publishing sort of case studies every month. There's something interesting to see. So come and find us there. Thank you very much.